Okay, finishing up today's lesson, we're graphing exponential functions of the basic form with no shift. Y equals a times b to the x. Specifically, for the first example, we're graphing y equals 2 times 3 to the x. So here's our directions. We're going to plot 2 points, we're going to draw an asymptote, and then we're going to draw the curve. So it's pretty simple. So let's plot our first 2 points. So we have x is 0, so 2 times 3 to the 0 power. What's anything to the 0 power? Well, that's 2 times 1, and so our first point is 0, 2. So we plot it, 0, 2. There we go, that's the 2. Let's do it again. 2 times 3 to the x, which is 1, is just 2 times 3. 2 times 3, which is 6. So now I have the point 1, 6. X is 1, y is 6. So I have 2 points, and that's all I need to do this kind of graph. So now I'm going to draw an asymptote. Well, what did we say about, we've seen with all of our graphs, these graphs approach, as x approaches negative infinity, y is going to approach 0. So we have our line and our asymptote, y equals 0, and now we can just draw the graph because we're going to connect through these 2 points. We know that as x approaches positive infinity, f of x is approaching positive infinity, and this way it approaches 0. Okay. What is the domain of the function? Where does the graph exist on the x-axis? Well, all real numbers, because it goes on forever in this direction. What is the range? Where does it exist on the y-axis? It exists, y is greater than 0, not equal to 0, just greater than. All right, that's all there is to it. Let's do it again. Now, one thing we noticed, this is, let's label it, this is a growth function, right? Because b is greater than 1. All right, next problem. So we're going to graph 2 points. We've got a new equation. We're going to graph 2 points. So we say 4 times 1 over 8 to the 0 power. That equals 4. Anything to the 0 power is 1, which equals 4. So my point is 0, 4. Let's graph it. 0, 4. Second point, 4 times 1 over 8 to the first power. That's going to be 4 times 1 over 8. Well, I multiply that together and I get 1/2. So my second point is 1, 1/2. Let's graph it. 1, 1/2. Okay, so let's draw that asymptote. We know that this is a decay function. B is less than or equal to between 0 and 1. So our graph, as x approaches positive infinity, the graph is going to approach 0. So this is the asymptote, y equals 0. Let's draw in the graph. So it goes up this way, comes down, and approaches the line y equals 0, but will never cross it. There we go. This is the graph, y equals 4 base 1/8 to the x, exponential graph. What's the domain? All real numbers. What's the range? Y is greater than 0. And what kind of graph is this? As x approaches positive infinity, the graph is approaching 0. So it is a decay graph. Okay. At this point, I'd like you to stop the tape and do exactly what we just did to the problems on the other side. Okay? I'm going to give you a chance to do it on your own. Stop the tape and do it on your own, and then I'll put up the answer so you can see it. So, if you did it correctly, your graphs should look like, there we go, for example number 1, your points were 0, 3, and 1, 12. And when you graphed it, it had a steep curve, it had an intercept of 0, 3. And what does this correspond to? 0, A. And what is our A? 3. Our next graph should look like this. It's got an intercept of 0a as well, 0, 2. It's a flatter curve. And what about this? This is a decay because as x approaches positive infinity, f of x approaches 0. Your points should have been 0, 2, and 1, 3/2, 1.5. So I also graphed one more point, and I got -2, 3.5, because I wanted to see how the graph was curving over here to the left. All right, that's it. I will see you tomorrow, or the next day.